CRISPR gene editing and all the massive dangers that are inherent to it. So I want to start off with my thesis that CRISPR gene editing is a technology with such massive potential to change literally everything we can conceive that there's no question that this will be a huge part of our future. And we have to know that while also knowing that the amazing versatility of this technology could also very well ruin humanity. So we need to be conscious about this polarity of the two futures we have with this. And because of that, we must be careful going into our exploration of this technology. So what is CRISPR? CRISPR was first observed in 1987 at Osaka University in E. coli bacteria. What researchers found is that this bacteria, they found a strange repeating code of DNA of a virus that attacks the bacteria inside the bacteria. And they later realized is what would happen is that the bacteria would send out this strand of DNA with this Cas9 protein and use this DNA like a mugshot of seeking out all the viruses around it, looking to match up that DNA. And if they find a match for that DNA, the protein will go in and just cut it out, killing the virus. And we discovered this, but then people were like, hey, what if we just took out the DNA of that virus and replaced it with, say, like a human gene that codes for cancer progeny? That can just be taken right out and then we can replace it. We continued down that line of thinking, and then in 2012, Jennifer Doudna and her team were able to make it into a process that we can use extremely easily called CRISPR. And it was quickly engulfed by the scientific community because of its ease of use. There were gene editing technologies before this, but I think the best way to convey the differences is with the typewriter and Google Docs. Old technologies are like a typewriter in the sense like you can go back and change something if you don't like it, but like you need to be able to white it out. You have to go back over with a typewriter, line it up correctly. It's not a clean process. But then with Google Docs, you see what you don't like, you just press delete, write exactly what you want. That easy. That's all there is to it. It's just completely different. Just like quantum computing, it just takes it all to a whole other level. So before I get into all of that, I wanted to make it very clear that this is also very good. We start with, for example, we can get stronger bacteriophages. We can make bacteria more weak, meaning that like our same antibiotics will be able to kill the stronger bacteria, putting a lot of potential in maybe like hospital sterilization. Then there's the potential to stop malaria by making it so malaria cannot infect mosquitoes to begin with. Again, another would be groundbreaking if we can make it work. Pest-resistant crops, we've been doing it for a while, but we can make it even better, meaning better food output. And then potential to cure genetic diseases, which I think is probably one of the most groundbreaking ones. Like if we know the gene marker for, say like sickle cell, just wipe it out and sickle cell's gone. And then adapting animal organs for human use, that's been a big field of research for a while with the high need for organ transplants. If we were able to make them in an industrial setting, it would be groundbreaking. So, I've been hinting at the huge amount of danger in this, but I've also been talking about how good it can be, so I just want to ask the question, what can go wrong? And I'll tell you right now. We start off with the God dilemma. This is one that most people can relate to. There's this sense that what we have now, the natural way of things, it works, and we shouldn't mess with it if we don't have to. People have some trust in how we're made. But I think I've discovered that once people become more aware of everything they can do with it, especially like genetic disease curing and like making crops better, that people start to be more like, all right, I'll see what CRISPR can do. And plus, whenever you start off with like animals and plants, quite frankly, it doesn't get that much more of a reaction out of people. People don't care too much about what happens with corn. But then humans is a whole other story. So I think this is a good breakdown of all the ways you can edit humans. We start with the axis of somatic versus germline editing, and then therapy versus enhancement. Somatic basically means whatever changes you're making are on the cells of your body, like arm cells. Whatever changes you make, it's going to be staying with you. Meanwhile, with